We're all familiar with different kinds of clouds: white puffy cumulus, dark nimbus storm clouds, wispy thin cirrus clouds. Not just beautiful to look at, clouds play an important role in Earth's climate. They're formed by water vapor, a naturally occurring gas created when water evaporates from lakes and oceans. Water vapor is also a heat-trapping gas. It's part of a dangerous feedback loop that's heating the Earth beyond its natural limits, accounting for about 60% of all global warming caused by heat-trapping gases in the atmosphere. As fossil fuel emissions raise temperatures, the atmosphere absorbs more water vapor, which then traps more heat, warming the planet further in an ever-amplifying loop. In fact, the water vapor feedback amplifies global warming from human activity between 2 and 3 times. For the past 30 years, Jennifer Francis has been studying how increased greenhouse gases affect the atmosphere.
Water vapor is just water in a gaseous form. When you take a pot of water and put it on your stove and boil it, you see steam, which is still in the liquid form, but then it disappears and it goes into the atmosphere and it's completely invisible. So the same kind of thing is happening in the climate system, where as we warm the air and we warm the oceans, more evaporation is occurring from the oceans and putting more water vapor in the atmosphere.
While some of this stays in the atmosphere and traps heat in gaseous form, some of it cools and condenses, forming clouds, which can both heat and cool the planet.
We still don't have good mechanisms, as good as we would like, for cloud feedbacks, because clouds are very complicated.
Clouds can lower the temperature because their white color reflects sunlight back into space, cooling the Earth, like on a hot sunny day when clouds offer relief from the heat. Conversely, clouds can trap heat below them, heating Earth's surface, like when it's warmer on a cloudy night than on a clear one. While a difficult challenge to unravel, scientists conclude that, on balance, clouds raise the temperature.
In the final analysis, it's going to make it capture more heat and cause more warming than cooling.
And as the climate warms, the oceans are also heating up, causing increased evaporation, creating even more water vapor, trapping more heat, leading to more evaporation, and becoming another amplifying loop. It's this combination of increased water vapor and the warming of the oceans that's driving hurricanes. Climate models predict that the stronger ones are going to become even more frequent in the future. Hurricanes aren't part of the water vapor feedback loop, but they're profoundly affected by it.
More than 30 years ago, we predicted that global warming would result in more intense storms. And we're beginning to see that even in places like Florida and the Bahamas, which are adapted to hurricanes. They're adapted up to a point, and when we begin to see stronger storms like Dorian, that adaptation doesn't mean anything.
In addition to water vapor, another atmospheric feedback loop is creating extreme weather, this one involving the jet stream.
The jet stream is this river of wind high over our heads, up where the jets fly, that encircles the northern hemisphere. And that jet stream is responsible for creating pretty much all the weather that we experience in this part of the world.
To illustrate, imagine a layer of air extending from the warm south to the cold north. Warm air expands, so the layer over the south rises up higher than the air over the north. If you sat on top of this layer of air in the south looking north, it would appear to slope downward. Because of gravity, the warm air higher up flows downhill just like water flows down a mountain. This downward movement creates a south to north wind. But because the Earth is spinning, this wind gets turned to the east and becomes a west to east flow of wind. That's the jet stream. The greater the temperature difference between the north and south air masses, the faster and stronger the jet stream winds blow. Historically, Arctic air has been much colder than the air to the south, keeping the jet stream fairly straight, with relatively small north-south meanders. But with the Arctic warming at 2 to 3 times the rate as the rest of the globe, that temperature differential has decreased. This weakens the jet stream winds, causing them to take larger swings north and south, which in turn impacts the weather.
This is the feedback loop. We're warming the Arctic, we're reducing the winds of the jet stream, we're seeing it take these bigger north-south swings, which then transfers even more heat from the south to the north into the Arctic, which makes it even warmer, which weakens the winds more, and it sets up this vicious cycle. The perception for all of us on the ground here is that it feels like our weather is getting stuck in one pattern for a long time. It could be hot, it could be cold, it could be rainy, or it could be dry.
Recent sobering examples are the multi-year drought in the western U.S. and the increase in wildfires. Both are connected to a larger north-south swing in the jet stream. We're now living in a world where extreme weather events like these are the norm, not the exception. Even if we could staunch the emissions of greenhouse gases today, these weather patterns may continue for a long time to come.
So the wet places are going to tend to get wetter. On the other hand, places that are already dry, they're also going to see more evaporation because of the air being warmer.
To prevent the weather from becoming even more extreme, we must stop adding fossil fuels to the atmosphere, heating the Arctic and weakening the jet stream, which warms the Arctic more. When we cut emissions, stop deforestation, and regreen the Earth, the Arctic will cool and the jet stream will regain its strength and return to its normal pattern, keeping heat from the Arctic and slowing or even reversing the extreme weather loop. It requires each of us doing our part. It's also going to take policymakers around the globe doing the right thing, incentivizing ways to lower heat-trapping gases in the atmosphere to restore the Earth and cool the planet.
I think the single most important thing we can all do is go and vote. And vote for leaders who understand that this is a big problem, that it's our doing, and that there's a lot of things that must be done to get that curve of warming heading in the other direction.